I'm Kourtney Chinnery, and I'm presently a junior at Bridgeway Academy. Today, I'll be performing an experiment for my chemistry lab class. We will be comparing polar covalent and nonpolar covalent compounds by observing the polar nature of molecules. Before this experiment, I'll be reviewing several terms. An element is a substance that cannot be broken down into any simpler components. Now, when elements combine, they form molecules. When molecules combine, they form compounds. Compounds are substances that can be decomposed into elements by chemical means. They are formed when elements, which are the basic building blocks of all substances, join together to form a new substance. Compounds can be classified as either ionic or covalent. An ionic compound contains at least one metal and one nonmetal, whereas a covalent compound contains solely nonmetals. So we have two different types of covalent bonds. We have a polar covalent bond and a nonpolar covalent bond. A polar bond is a covalent bond in which the electrons are shared unequally between the atoms involved. A nonpolar bond is a covalent bond in which the electrons are shared equally between the atoms involved. An example I'll be giving today is when two hydrogen atoms join together. Atoms join together based on the number of valence electrons in their outer shell. Most elements want to gain 8 valence electrons, like the noble gases, which are in row 8 on the periodic table. However, the hydrogen atom particularly only wants to gain 2 valence electrons. Hydrogen is number 1 on the periodic table, therefore it has 1 valence electron. When one hydrogen atom with 1 valence electron wants to gain another electron, it may join with another hydrogen atom. When both of these hydrogen atoms join together, they are both happy because they have 2 valence electrons in their outer shell, because they share that 1 valence electron. When these two atoms join together, because hydrogen is a nonmetal, there are 2 nonmetals combining. Therefore, they are a covalent bond. Now, since the hydrogen atom, since 2 of them are joined together, they have the same amount of electronegativity, because based on where they are located on the periodic table shows the amount of electronegativity that they have. The electronegativity increases from left to right on the periodic table. Since hydrogen is number 1 and it is on the far left of the periodic table, it has a low electronegativity, and since it's 2 hydrogen atoms in this particular bond, they are the same amount. So, therefore, the covalent bond they both have the same amount of electronegativity, and we have learned that a nonpolar covalent bond is in which the electrons are shared equally. Therefore, this particular bond is a nonpolar covalent bond. Now we will be beginning the experiment. The materials used in this experiment are a glass of water, vegetable oil, a styrofoam cup, a comb, and a pen, which we use to poke a hole in the bottom of the styrofoam cup. So, in this experiment, we will be observing, like I said, the polar nature of molecules. So, we will go over to the sink. Oh, first of all, we use the comb to comb the doll's hair in order to create a charge on the comb. So, we will be combing the doll's hair, and we comb quite a bit in order to create a charge. Okay, now I'll be going over to the sink and pouring this water. But in this case, I'll just use this. Okay. Now, as you can see, the water begins to move towards the comb. I don't know if you can see it. And that is due to the electrical charges that are produced when we combed the doll's hair. The comb gained a negative charge. Now, in H2O, we have 2 hydrogen and 1 oxygen. So, as a result, the oxygen has more of electronegativity than the hydrogen. So, it develops a partial negative charge. The hydrogen atoms then have a slight electron deficit, giving them a partial positive charge. Once you combed the doll's hair, the comb became negatively charged, attracting the partial positive charges on the hydrogen atoms. Therefore, that is the reason that the water was attracted to the comb once we combed the doll's hair. So now we'll be doing the same experiment, but we'll be using vegetable oil this time. So we'll be pouring the vegetable oil into the cup, and we will be looking at the stream. As you can see, the vegetable oil is not attracted to the comb. Oops. But once again, we'll go ahead and prove this we'll comb the doll's hair once again. And you can see, just in case, so you make sure you know. Okay, so we know that in this case, the vegetable oil is a nonpolar covalent bond, and it is not searching for any more electrons, and it is not attracted to the charges that are on the comb. So that is all I'll be doing in this experiment. I compared the polar covalent bonds with the nonpolar covalent bond, and thank you for watching this experiment. Bye.